Hey, we have here today another integral on the board. This is just dx over x cubed minus 1. I was actually looking back at the history and I noticed I've done the integral of dx over x cubed plus 1, but I've never done dx over x cubed minus 1. So to get started with this one, for my first step, what I want to do is just use the difference of two cubes on this denominator in order to split this up. So I can write this as x minus 1 times x squared plus x plus 1. And then from here, what I can do is split this up for partial fractions. So I can write this, we can split up our denominator and we can have x minus 1, and we'll have some value we want to find a. And then for the other piece, we'll have this x squared plus x plus 1. And in the numerator, I'm going to have bx plus c. And that's because we want the degree on this to be 1 less than our denominator. So that's why we have bx plus c there. And what we want to do from here is we just want to solve for these constants. We want to find out what this a, b, and c is. The way I can do that is actually by getting a common denominator and putting this back together into this form. So knowing the coefficient here is 1, we can set up an equation and solve for these three values. And one quick note, of course, you could use the cover-up method to get one value, but in this video, I'm going to just multiply the whole thing out. Usually once I start multiplying things out, you really can't stop me. So to get a common denominator here on this a over x minus 1, I'm going to multiply numerator and denominator by x squared plus x plus 1. So when I do that in the numerator, we're going to have a times x squared plus x plus 1. And then doing the same thing over here for the second one, we have our bx plus c. To get a common denominator, we'll multiply by x minus 1 over x minus 1. So I'll multiply my bx plus c times x minus 1. Then I'm just going to distribute this thing all the way out for both of these, and let's see what we have. And then from here, I'm just going to group like terms. So like we have this, for our x squared terms, we have an a x squared plus bx squared. So I'm going to write this as a plus b times x squared. And then I'm going to grab all of our x terms. Okay, so for that, we'll have a minus b plus c. And those are all of our x terms. And then lastly, what we'll do is just get our constant terms. So we're just going to have this a minus c here. So we'll write that a minus c. And again, we're just putting this fraction back together so that our numerator is all this. We know that our numerator has to equal in the end 1, because that's what we started with, and we don't want to change it. So what you can do with this 1, if you just think of it like all these other higher powers are going to be 0. So like if you think of, we could write 1 as 0x squared times 0x times just 1, then that gives us something to equate this to. So I can write like a 0x squared here, a 0x here, and write this one as 1. Well, if you do that, we really don't need x squared here, because we're just saying that a plus b is going to need to equal 0. So we can just kind of not worry about that. And the same thing here, we're saying for this equation, we need a minus b plus c to equal 0. And we can just solve this thing using any algebra technique that we want, substitution or elimination or whatever. So when I solved this system earlier, I got these three values for a, b, and c. So now that we have our values for a, b, and c, what I'm going to do is plug this back into our integral, and then we can continue. Okay, so now that we've plugged back in our a, b, and c values, we can do some integration. Like on the first one, this is an easy integral. Now this is going to be just 1/3 natural log, and then we'll have our absolute value of x minus 1 here. And then for this integral here, what I'm going to do is factor out a minus 1/3 in front, just to make this a little cleaner. So if I do that, we're going to have minus 1/3. We'll have in the numerator, this is going to become an x, and then we're going to have a plus 2 right here. Well, for this integral here, I just noticed that the derivative of this is going to be 2x plus 1. So what I want to do is kind of manipulate our numerator to get that. So what I'm going to do is multiply this by 2, but then I need to divide by 2. So then when I do that, I'm going to have a minus 1 over 6 out front here. Now let me just rewrite this so we're clear on what's happening. So we'll bring down our natural log of x minus 1 here. I'm going to have a minus 1 over 6 in front. Now distributing this in, we have 2x plus 4. But like I said earlier, the derivative of this is 2x plus 1. So let's do 2x plus 1 over x squared plus x plus 1. But then again, this was 2x plus 4 over here, so we have a plus 3 hanging out. So what I want to do is create like a separate integral for this plus 3. So we're distributing in our minus 1 over 6 here. And then for this integral, we're just going to have this 3 in the numerator. And this is all going to be over x squared plus x plus 1. Sorry, that's a mess. I'll fix it. Okay, so we have our 3 over here. Just seeing again that 2x plus 1 plus 3 gets us back to our 2x plus 4 from the previous board. And then what I'm going to do, let's just bring this 3. Let's bring this 3 outside of the integral. Over 1 over 6 is going to be the same thing as minus 1 over 2. Okay, now from here, let's just focus on this integral really quick, because it's set up perfectly for our u substitution. So what I'm going to do, again, our u is just going to be our denominator. So let's see, we'll make our u equal to x squared plus x plus 1. And then our du, taking the derivative, that's a weird looking du, but anyway, derivative of this is going to be 2x plus 1 dx. And again, that's what we have in the numerator. So this is actually going to be, for this integral here, this is actually going to be just du over u. Very simple. So this is going to be natural log absolute value of u, but u is just x squared plus x plus 1. And it may not be totally apparent, but if you look at a graph, you'll notice this thing is always positive. So I'm just going to remove absolute value here, and we can just use parentheses on this. Okay, and now we just have one integral left to finish this off. And what I'm going to do for this one is complete the square on this thing. So for completing the square, notice there's just like a 1 coefficient on this x. What I'm going to do is divide the 1 by 2. So we're going to write this as x plus 1/2 squared. When you multiply that out, you're going to have just x squared plus x plus 1/4. Well, we have a 1 here. So what I can do is add a 3/4 to the 1/4, and that's going to give us our 1. And one other thing, I just want to rewrite 3/4. What I'm going to do is let's just write this as square root of 3 over 2 squared. And now this is perfectly set up for our arctan formula. Let's just look at that really quick. Okay, so we have our arctan formula over here on the right, and we're going to use that. Now this is just like a little more complicated than how we use it sometimes. In this case, our u value is going to be this x plus 1/2, and our a is going to be square root of 3 over 2. So using this, we want the reciprocal of our a values. This is going to be 2 over square root of 3 arctan, and then our u value is going to be this x plus 1 over 2. Okay, now I'm in an awkward spot, so I'll erase this. Okay, again, here we're going to have our 1 over a basically, so this is going to be this reciprocal, same thing over here, so we'll have 2 square root of 3. And so I'm just going to clean this up by multiplying in this 2, so let's just rewrite this. Okay, so next I'm just going to take this value and we're going to plug it back in and finish this off. Okay, so at this point we're basically done. All I'm going to do a little cleanup here. So all I want to do is just cancel these 2, so we have 1 over square root of 3. And for 1 over square root of 3, you can just rationalize this, right? So this is going to be the same. If you multiply that out, you're going to have the same thing as square root of 3 over 3. So I'm just going to clean this up and write it as square root of 3 over 3. And this is going to be our final solution. We're going to have 1/3 natural log x minus 1 minus 1/6 natural log x squared plus x plus 1 minus square root of 3 over 3 arctan 2x plus 1 over square root of 3 plus c, and we're done. So we'll stop it there. Thanks everyone for watching today. Have a great day.